this process of removing arsenic, Ravalji, in the process of removing arsenic, and he has a catalytic process, he says, and we all know, pH control is the key. Now, how do you therefore keep, he says he's able to manage 7.2, 7.3, 7.1, you know, close to neutral. Any take on that, Ravalji? On the process of the science?
Honestly, I am an all-timer. The permissible limit is 0.05 ppm.
Correct. No, he's talking
now
pH
talking about 8 ppm and 9 ppm and bring it down.
Not 8 ppm. He's talking about pH value of 7.2.
The source of arsenic.
Yeah.
Power plants, cement factories, tanneries, insecticide manufacturing company. We are not addressing the source. And then we are talking about technology, which is a cost.
Oh, okay.
You see?
Okay.
And then often we talk that prevention is better than cure. Where are we going?
Rick?
Well, I think you've got two things. I agree. Polluters should pay and polluters shouldn't be generating. So there's an issue there and we can solve for that. But the fact is that you've got groundwater supplies today that people are exposed to that need to be treated. They are the problems created by the past. We can't ignore them. And so
I fully agree with you. My point is, if the cleanest water, whatever we can imagine, is near the surface of land, absolutely, we have not yet learned to preserve that, recognize that. And then we are talking about tube well water, and then of course Chambal area has a very high source of arsenic, lead and nickel and all that. And Professor Ligi Phillips of Chennai IIT, she is specialized on that. But then it is all about cost and for special people to operate and look after the plant. I'm unable to connect the whole advancement with 1.4 billion population.
Well, we start, how do we eat an elephant? We chop it up into little pieces and then we, step by step. But, we have to start somewhere. And I think the first thing we need to do is establish, we've done the demonstrations, everything here, but a demonstration in America is worth zero when it comes to deploying a technology in a new market like India, which has had so many unfortunate experiences with people turning up and saying, we have the solution. We want to see this demonstrated, validated by reputable institutions. We're prepared to invest in that, as we have done here, because we have total faith in this product. We didn't invent the chemistry. We just invented a very clever way of delivering safely a reagent. It's that simple and that complicated.
Should I dare ask what that, like the French call it the ginseng core, on the ECT process, where you have cleverly skirted the challenges of ECT?
Yeah, it's a good one, because everyone says, oh, we're electrocoagulation. In fact, we work very closely with the people at Berkeley, Ashok Gadgil and his team. In fact, one of his research chemists is joining us. So the problem with electrocoagulation is you treat, everything has to go through the system, the whole volume. We take a side stream. And the problem with that is you've got a very large mass that you're trying to treat. And the problem is that the place you're doing it, the generator, remember my little battery looking type thing? There you have that is the contactor. So the reaction takes place on the plates. And there's your problem, because the plates become corroded, passivated, and you lose total control. Correct. We avoid it by the side stream. And we can keep the plates fresh with ultrasound and various other things, which you cannot do when you have a huge electrolyte.